Yes, in the last class we discussed about the molecularity of the chemical reaction. Next one is very important one, order of the chemical reaction. Order of the chemical reaction. Order of the chemical reaction. Before going to discuss the order of the chemical reaction, in the last class briefly I explained what I mean by elementary chemical reactions and complex chemical reactions. A chemical reaction which occurs in a single stage or one step is called an elementary chemical reaction, and a chemical reaction which occurs in multiple steps by means of reaction mechanism are called complex chemical reaction. You know, the complex chemical reactions are carried by means of the reaction mechanism. In your first piece, I hope you studied about the various reaction mechanisms like free radical mechanism, nitration mechanism, aromatic nitration mechanism, aromatic chlorination mechanism, aromatic sulfonation mechanism, aromatic alkylation or Friedel-Crafts alkylation mechanism, or acylation mechanism. What is the reaction mechanism? A chemical reaction that takes place in different steps or the number of steps. A chemical reaction which occurs in a number of steps, and conversion of number of steps means they are due to the formation of the intermediate products. But the intermediate products are unstable, then it leads to the formation of the final product by means of reaction, final step of the reaction mechanism. Formation of the various reaction intermediates and conversion of these reaction intermediates into the final product or products is called reaction mechanism. Formation of various intermediates. What about complex chemical reaction? Complex chemical reaction. Before going to define the order of a chemical reaction, we can discuss about the complex chemical reactions or complex chemical reactions. What about complex chemical reactions? Usually they occurs by means of number of steps. They occurs by means of number of steps. Not a single step chemical reaction, it is a multiple step chemical reaction. They occurs by means of number of steps. Several steps are there. Number of steps means several steps. By means of reaction mechanism, via a reaction mechanism. Reaction mechanism. What is the reaction mechanism? A chemical reaction proceeds by the formation of the various reaction intermediates and conversion of these reaction intermediates into the final product or product is called reaction mechanism. What is by reaction mechanism? A chemical reaction proceed by formation of various reaction intermediates and conversion of these reaction intermediates into conversion of these reaction intermediates into final product or products is called reaction mechanism. For example, A is the reactant, directly it gives rise to P in a single step, in a single step, in a single step. That is called elementary reaction. That is called elementary reaction. Elementary reaction. In another hand, suppose A is the reactant that react to give the B, then B is the reactant that is intermediate, that is B is B star. Suppose B star that gives rise to C star, and C star suppose that gives rise to final product. This is B star or C star intermediates. B star or C star are the reaction intermediates. Intermediates. They are not final product. Intermediates. Therefore, the same reaction that occurs in 3 stages, the same reaction occurs in 3 steps. 3 steps. This is called complex chemical reaction. This is called complex reaction. A reaction which occurs in number of steps is called complex chemical reaction. A complex chemical reaction, they occurs by means of number of steps via means of reaction mechanism. What is the reaction mechanism? A chemical reaction proceeds by the formation of reaction intermediate, various reaction intermediates, and conversion of these intermediates into the final product or products. That is called reaction mechanism. That is called reaction mechanism. And conversion of these reaction intermediates into these reaction intermediates into these reaction intermediates. Conversion of these reaction intermediates. Intermediates into final product or products is called reaction mechanism. Reaction mechanism. For example, consider a chemical reaction. Consider a chemical reaction. Consider a chemical reaction. Consider a chemical reaction. Consider a chemical reaction 2NO2Cl, 2NO2Cl, nitrosyl chloride, that gives rise to nitrogen dioxide and chlorine. Nitrogen dioxide into chlorine. Now it is an elementary chemical reaction, you are thinking, but it is not an elementary chemical reaction. It occurs by means of various reaction mechanism. It occurs by means of the mechanism of the chemical reaction. The mechanism of the chemical reaction. The mechanism of the chemical reaction is given by, here 2 molecules are there, but at a time I will take only one molecule. In the first step, NO2Cl, that gives rise to NO2 plus Cl. NO2Cl, that gives rise to NO2 plus Cl. This second step, one more molecule of the NO2Cl that combines with Cl. One more molecule of the, since 2 molecules are there, in the first step one molecule of the NO2Cl that gives rise to NO2 plus Cl. In the second step, the second molecule of the NO2Cl that combines with Cl, that combines with this Cl. This Cl means step number 1. Then it gives rise to NO2 plus Cl2. NO2 plus Cl2. Here two steps are there. Here this is an intermediate. This is intermediate. But among these two, one is slow step and one is fast step. This is the slow step. This is the slow step and this is fast step. This is slow step and this is fast step. The slowest step of the chemical reaction. If suppose the chemical reaction occurs by means of various stages, out of this first stage or second stage or third stage or fourth stage, one step is the slow step of the chemical reaction. That step is called rate determining step. Chemical reaction occurs by means of various reaction mechanisms that I mentioned. If suppose a decomposition of this nitrosyl chloride, that gives nitrogen dioxide and chlorine, but the mechanism of the chemical reaction that occurs by means of two steps. In the first step, one molecule of the nitrosyl chloride gives nitrogen dioxide and chlorine. This is active chlorine, that is the slow step. In the second step, nitrosyl chloride, second molecule of the nitrosyl chloride that react with this intermediate chlorine, then it gives rise to NO2Cl2. Here, but among these two stages are two steps. One is the slow step of the chemical reaction and one is the fast step of the chemical reaction. In a complex chemical reaction, so the rate determining step is the slow step. Rate determining step is equal to rate determining step. Rate determining step is slowest step of the chemical reaction. This is very important. Slowest step of the chemical reaction. Slowest step of the chemical reaction. Slowest step of the chemical reaction. Chemical reaction. This is called RDS, rate determining step. That is often called as some textbook. It is mentioned as a RDS. Therefore, how do you obtain the rate law? That's the rate is equal to what? Rate is directly proportional to. This is very important. Rate is directly proportional to. This is slowest step of the chemical reaction. You have to explain the rate. Therefore, rate is directly proportional to concentration of the nitrogen dioxide into concentration of chlorine. Concentration of nitrogen dioxide into concentration of, that is with respect to the reactant. That is with respect to the reactant. That is with respect to the reactant according to the law of mass action. Rate is directly proportional to the concentration of NO2Cl. Concentration of NO2Cl, or rate is equal to K into concentration of NO2Cl. Concentration of NO2Cl. This is a rate law or rate equation. Rate equation. In this way, we can predict the law derived from rate law, that is derived from experimentally determined rate equation for the reaction. Therefore, this is equal to rate equation. This is equal to rate equation. Rate equation. Rate equation. Is it clear? Therefore, if suppose the chemical reaction that occurs by means of various steps, you have to identify the slowest step of the chemical reaction. In the slowest step of the chemical reaction, you have to write the rate law. Therefore, rate is directly proportional. According to the law of mass action, rate of a chemical reaction is directly proportional to the molar concentration of the reactant provided temperature is constant. Therefore, rate is directly proportional to the concentration of the NO2Cl. Therefore, rate is equal to K into NO2Cl, where K is called rate constant of a chemical reaction. Where K is equal to rate constant or velocity constant. Rate constant or velocity constant of a chemical reaction. Rate constant or velocity constant of a chemical reaction. Rate constant or velocity constant of a chemical reaction. Is it clear? This is about the rate law in complex chemical reactions. Complex chemical reactions. I will give one more example. Example number 2. Example number 2. Suppose the reduction of nitric oxide. The reduction of nitric oxide. Both are in gaseous state. That gives rise to 2H2O plus N2. 2H2O plus N2. This is the reduction of, what is it? Reduction of the nitric oxide that gives rise to water and nitrogen. All are in gaseous state. All are in gaseous state. This is liquid state and this is gaseous state. This is the reduction of the nitric oxide into water. Experimentally, rate equation, the mechanism of the chemical reaction is given by mechanism of the chemical reaction. Mechanism of the chemical reaction. Mechanism of the chemical reaction is given by step number 1. Mechanism of the chemical reaction is given by step number 1. Step number 1. 2NO gives rise to 2NO. That gives rise to N2O2. This is peroxide. N2O2. This is peroxide. This reaction that occurs in two steps. There is a balance, equilibrium chemical reaction. Equilibrium chemical reaction. In step number 2. In step number 2, N2O2 that reacts with N2O2, it reacts with one molecule of hydrogen, then it gives rise to one molecule of hydrogen that gives rise to N2O plus H2O. N2O plus H2O. N2O plus H2O. In third stage, in step number 3, N2O is intermediate. N2O2 is intermediate and N2O is also intermediate. In third stage, N2O plus one molecule of the H2 that gives rise to N2 plus H2O. N2 plus H2O. Now balance the chemical equation. Now add equation number 2 and equation number 3. And where is the equation 1, 2, 3? Equation 1, 2, 3. N2O2 get cancelled. N2O get cancelled. Therefore 2NO plus H2 gives 2H2O. Then it gives rise to N2 plus 2H2O. H2O plus H2O, 2H2O. And then, but this is the slowest step of the chemical reaction. This is a slow step of the chemical reaction. And this is the remaining two are the fast step of the chemical reaction. Sorry, the first one is the fast step of the chemical reaction. First one is the fast step of the chemical reaction. Second one is the slow step of the chemical reaction. And third one is the fast step of the chemical reaction. Fast step of the chemical reaction. This is by means of experimentally determined rate equation for the reactions. Experimentally determined rate equation for the reaction. Experimentally determined rate equation for the reaction. Now, intermediates are N2O2, N2O2 and N2O. This is intermediate and this is intermediate. Intermediates or intermediates. N2O2 and N2 are intermediates. Now, which is the slowest step of the chemical reaction? Second step is the slowest step of the chemical reaction. Therefore, according to the law of mass action, consider step 2. Consider step 2 because it is the slowest step. Among various number of steps, one of the step which is the slowest step, that is called redetermining step of the chemical reaction. Therefore, rate is directly proportional to N2O2 into H2. Therefore, rate is equal to K into small letter k into N2O2 into H2. Our objective is to eliminate N2O2. Our objective is to remove N2O2. Remove N2O2 because it is interested in reaction intermediate. Then consider this reaction 1 from equation 1, from step 1, rate is directly proportional to what? Rate is directly proportional to, that is NO to the power of 2. Rate is directly proportional to NO to the power of 2. How to remove NO2? Now this is in equilibrium with this one. N2O2, that is in equilibrium with N2O2, that is in equilibrium with rate is directly proportional to, rate is equal to suppose K1 into NO whole square. Since it is a reversible chemical reaction, this is for forward direction. For backward direction, say that is equal to, rate is directly proportional to N2O2. Therefore, that rate is equal to, assume that is a K2 into N2O2. Since it is an equilibrium chemical reaction, and hence these two are equal. Therefore, K1 into NO whole square. Is equal to K2 into N2O2. Now here K2 into N2O2, that is in terms of K1 into NO whole square. Can I replace this one N2O2? Then now what do you mean by N2O2 here? N2O2 is equal to K1 by K2. N2O2 is equal to N2O2 is equal to what? K1 by K2, K1 divided by K2 into NO to the power of 2. Now substitute this in equation number 1. Suppose this is an equation number 1. Suppose this considers an equation number 1. This is an equation number 2. This is an equation number 3. This is an equation number 4. This is an equation number 4. And this is equation number 5. This is an equation number 6. Suppose this is equation number 7. Substitute in equation number 1. Substitute N2O2 in equation number 1. substitute N2O2 value in equation number 1, N2O2 in equation 1. Then what happens? N2O2 substitute in equation 1. Now K into K1 by K2, rate is equal to K into K1 by K2, in place of N2O2 you have to substitute NO wholes to the power of 2 into H2. K into K1 by K2 NO, because N2O2 is a reaction independent. That is the objective why we have to remove this N2O2 from the reaction by rearrangement of all the equation. Then for rate is equal to K into K1 by K2 into NO to the power of 2 into H2 to the power of 1. H2 to the power of 1. This is very important. What is this K1? K1 is nothing but forward reaction, K2 is equal to for backward reaction, or you can replace Kf divided by Kb, or you can replace, that is a K1 by K2 is equal to Kf divided by Kb, that is velocity constant of the forward reaction divided by velocity constant of the backward reaction, Therefore, rate is equal to K into Kf divided by Kb into NO that is how we can evaluate the rate in terms of velocity constant of a forward reaction, velocity constant of the backward reaction. Okay. Now come to the very important concept, that is order of a chemical reaction. Order of a chemical reaction. Order of a chemical reaction is the sum of the powers of the concentration terms in experimentally determined rate equation for the reaction. Sum of the powers of the concentration terms. Consider a chemical reaction. Suppose A plus B gives rise to C plus T or product. A plus B gives rise to C plus T or product. Then rate equation for the above equation is given by molar concentration of A into molar concentration of B. Assume it is an experimentally determined rate equation. Suppose this is the power 1. Therefore, if suppose it is an experimentally determined rate equation for the reaction, order of a chemical reaction with respect to A is 1, order of the chemical reaction B is with respect to 1, therefore overall order of the chemical reaction is 1 plus 1, therefore the total order is equal to 2. Order of a chemical reaction with respect to A, order of a chemical reaction with respect to A, order of a chemical reaction with respect to A is 1. With respect to A is 1. Order of a chemical reaction with respect to B is 1. Order of a chemical reaction with respect to B is 1. Therefore, overall order of a chemical reaction, overall order of a reaction is 1 plus 1 is equal to 2. Overall order of a chemical reaction is equal to 1 plus 1, that is equal to 2. Overall order of a chemical reaction 1 plus 1, that is equal to 2, provided it is obtained by the experimentally determined rate equation for the reaction. Now, what is the order of a reaction? Order of a reaction. Order of a reaction. It is the sum of the SEM sum of the powers of the it is the sum of the powers of the experimentally determined powers of the concentration terms. In the experimentally determined rate equation for the reaction. Experimentally determined rate equation for the reaction. It is the sum of the powers of the concentration terms in the experimentally determined rate equation for the reaction. If consider A plus B suppose gives rise to product or products, then rate is equal to A to the power of A into B to the power of B. Assume it is an experimentally determined rate equation. Order with respect to order of a reaction A with respect order of a reaction with respect to A. Order of a reaction with respect to A is equal to small a. Similarly, order of a reaction with respect to B. Order of a reaction with respect to B is equal to small b. Therefore, overall order of a reaction is equal to A plus B. That is how we can determine the order of the chemical reaction. Now, what is the difference between order and molecularity of the reaction? This is very important question that already mentioned. Order of a reaction can be 0 Order of a reaction can be 0 or fraction or whole number. Order of a reaction, whole number or whole number. If order of reaction is 0, they are called zero order chemical reaction. In such cases, the rate is independent of the initial concentration of the reactant. Order of the reaction will be fraction because in experimentally determined rate equation or in rate law, if the sum of the powers of the concentration term suppose seems to be fraction, then the overall order of the reaction is said to be fraction. Order of the reaction may be whole number, that is 1, 2, 3 and so on. Therefore, based upon this, we have first order reaction, second order reaction and third and nth order chemical reaction and so on. Therefore, order of the reaction may be 0. In such cases, the rate is independent of the initial concentration of the reactant. Order of the reaction may be fraction. In rate law expression, if suppose the sum of the powers of the concentration terms is found to be fraction, then it is considered as a fractional order chemical reaction. If suppose the sum of the powers of all the concentration terms in the rate law, if suppose it is a complex chemical reaction, the slowest step of the chemical reaction is nothing but the rate determining step of the chemical reaction. In such cases, if suppose the rate expression for such type of the chemical reaction is a whole number, then it is called as a first order, second order, third order and nth order chemical reaction. This is very important one. Whereas molecularity of a chemical reaction is always whole number, order of the chemical reaction will be 0 or fraction or whole number. Whereas a balanced chemical reaction is required in the determination of the molecularity of the chemical reaction, experimentally determined rate equation for the reaction is required in the determination of the order of the chemical reaction. Very important question, mention the differences between order and molecularity of the chemical reaction. Very important question. Make the two columns. In first column, molecularity of the chemical reaction. In second column, order of the chemical reaction. You have to define. This is a very important question for your board exam preparation. Mention the differences between order and molecularity of the chemical reaction. Very important one point is our molecularity of the chemical reaction is always whole number. Order of the chemical reaction may be 0, may be fraction or a whole number. While determining the molecularity of the chemical reaction, the balanced chemical equation is required, where the sum of the coefficient of the various reactants in the balanced chemical equation that represents the molecularity of the chemical reaction, where the sum of the powers of the concentration terms in the experimentally determined rate law or rate equation for the reaction, that is called order of the chemical reaction. Is it clear? After knowing the experimentally determined rate equation, only you can determine the order of the chemical reaction. Order of the chemical reaction. Important question. Mention the differences between order and molecularity of a chemical reaction. Mention the differences between order and molecularity of a chemical reaction. Order and molecularity of a reaction. Order and molecularity of a reaction. Order and molecularity of a reaction. Very important question. Usually in board exam they are asking, mention the differences between order and molecularity of a chemical reaction. Order and molecularity of a chemical reaction. Make 2 columns in your notebook. Make 2 columns in your notebook. Make first half is molecularity and second half, first half is order and molecularity. This is order, first half is order, second part is molecularity. In any differences, first you have to write the definition. Whatever may be the differences. In most of the exams they are asking, mention the differences between the two. How to present this question? Make 2 columns. First column put one component, second column put another component. Where the first difference, that should be the definition itself. Definition itself. First define order of a chemical reaction. Definition. It is the sum of the powers of the concentration in experimentally determined rate equation for the reaction. Write the definition of these. Whereas it is the number of reacting species. It is the first definition. Definition. You know the definition? You know the definition of order and molecularity. Write it. Write it. Second one, molecular order of a chemical reaction may be 0. Order of a chemical reaction may be 0. It can be fraction, it can be 0. It can be fraction. It can be fraction and it can be 0. This is very important. It cannot be fraction, it cannot be 0. That already mentioned in molecularity. It cannot be fraction, it cannot be fraction and it cannot be 0. It cannot be 0. It can be fraction, molecularity cannot be fraction, order cannot be 0, order can be 0, molecularity cannot be 0. It is an experimental fact. 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 In the definition itself, it is an experimental fact. By performing experiment only we can determine the order of the chemical reaction. It is a theoretical. It is a theoretical. By seeing the balanced chemical equation, it is a theoretical. It is a theoretical. By seeing the chemical equation only we can determine the molecularity of the chemical reaction. The term order is applicable to, applies to the overall reaction. The term order applies to the overall reaction. The term order applies to overall reaction. Overall reaction. The term order is applied to overall reaction. Overall reaction. But it is applicable to the term molecularity is applicable to the slowest step. The term molecularity is applicable to slowest step. Slowest step of the reaction. Slowest step of the reaction. The term molecularity is applicable to the slowest step of the chemical reaction. This is very important question. Mention the differences between order and molecularity of a chemical reaction. Usually they will ask in 2 marks question. Mention at least 4 differences among these. Mention it is. But first difference, that should be the definition itself. Out of these 4, you can write any 3. Okay. Therefore, definition that should be pakka. Whereas the order of the chemical reaction is the sum of the powers of the concentration terms in the experimentally determined rate equation for the reaction. That should be there in the first line. Molecularity is the sum of the numbers of the molecules of the various reactants participating in the balanced chemical equation, as that is called molecularity of the chemical reaction. Okay, this is very important question in this chapter.